Okay, this is section 6.3 and 6.4. We're going to combine these two sections into one. This section is on a process called elimination. Would you please title your notes, Elimination. In Algebra 1, we're going to learn 3 methods to solve systems. We'll solve by graphing, which we've done. We found where the 2 lines intersect. We're going to solve by substitution. That's what we did last week, last Thursday, Friday. And today we're going to learn a method called elimination. Of the 3, I think students prefer elimination just because it's nicer. Okay? Substitution works good sometimes, graphing works good sometimes, but elimination just seems to be a nicer process. In order for elimination to work, we have to have opposite terms. We've talked about opposites before, opposite terms. Opposite terms are terms that add to 0. For example, 3x and negative 3x. Those are opposite terms, aren't they? If I was to add those two, or subtract them, they would add to 0, wouldn't they? If we have negative 7y and a positive 7y, wouldn't those add to 0? Okay. Guys, if you're doing something else, you need to put it away. I need your undivided attention on today's lesson. Put it away. If we have something like 6x and a negative 5x, are those opposite terms? No. When we add those together, we're going to get 1x and not 0. So they're not opposite terms. So if we don't have opposite terms, we'll need to make them opposite terms, and I'll show you how to do that in a bit. Let's look at the first example. Please copy this into your notes. 3x plus y equals 5, and 2x minus y equals 10. We are solving this system. We want to get an ordered pair where these 2 lines are going to intersect. I could solve it by graphing, I could use substitution, or I could use this elimination method. Elimination will work if you have opposite terms. Do you guys see that we do have opposite terms in this problem? We have y and we have negative y right below it, don't we? So we're going to add these 2 equations. I'm going to add them vertically, up and down. I'm going to add the x's, I'm going to add the y's, I'm going to add the constants. They all have to be lined up. Now when I add the y's, aren't they going to cancel out? They're going to add to 0. And I want that to happen in elimination. When I add the x's, 3x plus 2x, I get 5x. And then add the constants, I get 15. Now I have an equation with only x's, correct? I can solve. How would you solve this equation? Divide by 5, so x is 3. The x coordinate is 3. Let's put this value back in, just like we did on substitution, put 3 back in for x, and solve one of these equations for y. It doesn't matter which equation I use. I think I'm going to use the first equation. So in place of x, I'm going to put 3. So x is coming out of the problem, and in its place is going 3. 3 times 3 is 9. Plus y equals 5. Subtract 9 from both sides. Y equals negative 4. So these 2 lines should intersect at 3, negative 4. I would like to confirm that they really do intersect there by graphing it on desk notes. So if you don't have your Chromebook, you can just follow along with me. Are 3x plus y equals 5. And 2x minus y equals 10. So I've got these 2 equations graphed here on my coordinate plane. The point of intersection is right there, 3, negative 4, which is also what we got when we used elimination. So just a quick and easy way to check ourselves, just like we did previously. 3, -4 is our solution. If we don't have Desmos, if we don't have access to that like on a test or a quiz, what's another way we could check this answer? Just substitute it in. 3, -4 is the only ordered pair that works in the first equation and in the second equation. It's the only ordered pair out there. There's not another one out there. So if it doesn't work in either one, this is not the right answer. How about this one? We have x plus 2y equals 4, and negative x plus y equals -1. Do we have opposite terms? Yes, if I add those x's together, x and negative x, they're going to add to 0, and I want that to happen in elimination. I want one of the variables to cancel out. When I add the y's, 2y plus y is 3y equals 3. 4 plus a -1 is 3. Go ahead and solve. We'll divide by 3. So y equals 1. So I know I'm going to have an ordered pair answer. I know that that y coordinate is going to be 1. To find the x coordinate, we're going to substitute back in. And remember, it doesn't matter which equation we use as long as that equation has an x and it has a y. I'm going to use the first equation. So x plus 2 times 1 equals 4. 2 times 1 is 2. So if we're solving for x, I'll subtract 2 from both sides. So x equals 2. The solution is 2, 1. I want you guys to try this next one on your own, and then we'll compare answers to see if we agree. We have 4x plus 3y equals 16, and 2x minus 3y equals 8. Let's go ahead and add these equations. Please solve, and then we'll compare answers here in just a second. When I add these two equations together, I get 6x equals 24. We'll divide by 6. So x is 4. In my ordered pair, I know it's going to be 4 comma something. So put 4 back in. 4 times 4 plus 3y equals 16. We'll subtract 16. So 3y equals 0. Divide by 3. And y is 0. And if you're not confident in your answer, if you feel like something's just off, graph it, make sure, and then go back and rework it. Alright, so sometimes we're not going to have opposite terms and we need to explore what we're going to do when that occurs. So look at this example with me. X plus 6y equals 5, and x plus 3y equals -10. You see what I mean? We don't have opposite terms, do we? If we add these two equations together, the x's aren't going to cancel out, and neither are the y's. So there's a couple of things I could do. One of them being multiply. I can multiply one or even both of the equations if necessary to get opposite terms. I could multiply that second equation by -2. What variable would that cancel out or eliminate? When I multiply by -2, that'll give me -2x, -6y, and a +20. It would cancel out the y's, wouldn't it? I could have multiplied this second equation by -1. If I multiply by -1, that gives me -x minus 3y equals +10. If I multiply by -1, what variable will that cancel out? The x. It doesn't matter which one you do, you're going to get the same answer at the end. Okay? We just need one of those variables to cancel out. I've got -1 up there, so I'm going to go ahead and go with that. First equation is going to stay the same, but the second one's going to be -x minus 3y equals a +10. going to go ahead and just cross off this middle equation so I don't think that it's still there. I replaced that middle equation with the third equation. Now I'm going to add these two equations together, the top one and the bottom one. When I do that, the x's are going to cancel out. When I add the y's together, 6 plus negative 3y, that's 3y equals 15. We can divide by 3. Y equals 5. So now I'm going to have an ordered pair, and it's going to be something, comma, 5. Let's put 5 back in. I can put 5 into any of those three equations on the top. The first, the second, or even that third equation. It doesn't matter as long as the equation has an x and a y. I'm going to use the first equation. So I have x plus 6 times 5 equals 5. 6 times 5 is 30. To get x by itself, I would subtract 30. X equals negative 25. Negative 25, comma, 5. I want to try one more with you, where we have to make opposite terms. Here's our last example. We have negative x plus y equals 1, and 2x plus y equals negative 2. Do we have opposite terms? Not to start with, but I could easily make them opposite terms. Does anyone have a suggestion of what we could do? Yes, multiply the second equation by negative one, that would be perfect. Mason, when we do that, what variable is that going to eliminate? Very good. Let's multiply that second equation by negative 1. Did anybody say multiply the first equation by positive 2? That would have worked also, because that would eliminate your x. It doesn't matter. So Mason suggested multiply the second one by negative 1, so let's do that. We have negative 2x minus y equals a positive 2. So the second equation is no longer, I'm going to use the first equation and my third equation. Stay with me, guys. Need you to focus, we're almost done. Negative x minus 2x is negative 3x. The y's are going to cancel out, equals a positive 3. Divide by negative 3 on both sides. X equals negative 1. Plus negative 1 comma something. How am I going to find that other value? Substitute it back in. And again, it doesn't matter which equation. I'm going to use the second equation. So 2 times negative 1 plus y equals negative 2. So negative 2 plus y equals negative 2. I'll add 2 to both sides. Y equals 0. Negative 1, comma 0. How many of you think you're going to like elimination a lot better than substitution? That seems to be the consensus among my Algebra 1 students every year, that elimination is just nicer. So today we're practicing using elimination. I want you to be familiar with all three methods, the graphing, the substitution, elimination. On your test and even your quiz that you're going to take on Thursday in here, I want you to solve systems by graphing. I'm going to ask you to solve using substitution. I'm going to ask that you solve using elimination. So make sure you do know how to do all three methods. All right, we're out of our book today. So you need your textbook. If you don't have one, borrow one from the shelf. We're on page 352, looking at numbers 7 through 18.